I'm glad to welcome you who are interested in being a PhD student in computer science. We are at Eötvös Loránd University in Budapest, and I would like to introduce first myself. I am Professor Zoltán Horváth, the head of the Doctoral School of Informatics at Eötvös Loránd University. We would like to inform you about the doctoral studies at us. First of all, in Hungary, you have a doctoral study of 4 years in two parts. The first 2 years, you should take some courses. You start your research, then you have an exam, a comprehensive exam, when we decide whether your progress is appropriate. And then you have a second period of your studies, another 2 years, where the main focus is on research. In total, you should collect 240 ECTS credits. The goal is that you create new knowledge and you publish your results in high-quality research papers. And finally, when you complete the 4 years of studies, you have to prepare your thesis, PhD thesis, and you have 1 more year to submit this thesis, PhD thesis, and then start your defense. What kind of topics you can choose? We have 6 different doctoral programs as part of our PhD school. First of all, we have a program on software technology, and theoretical part of computer science. We have another program for data science, networks and information systems. A third one for scientific computing and numerical methods. Then we are interested in teaching methodology of informatics. We have a program for geoinformatics and one for IT solutions in engineering. There are very hot topics you can choose for yourself, like quantum computing, cybersecurity, static analysis of source code of software, including identifying code vulnerability, human-centered AI, autonomous driving, type theory, and many others. The question is, of course, which one you would like to choose and who should be your supervisor. So you should choose a research question in which you are motivated, and in a topic where you can tell what is the expected result in 4 years you will produce, what kind of impact you will have on the world if you are successful to produce the research result. How to find a good research topic? We offer you some help. We involve industrial partners, and we offer real research challenges which are involved and which are offered by these industrial partners for us. And we have industrial departments for this purpose. We have joint industry university project labs, and you can join to these departments and project labs and work in a team and produce results which will be used by our industrial partners, and you get a feedback whether your result is useful and whether your results can be used in innovation processes, whether your results has an impact in business, and which results may have an impact on the competitiveness of the industry and the society. And actually very important that you can join research teams, which research teams are at the state of the art, and the head of these research teams are excellent researchers who can be your supervisors. I would like to introduce you a few such industry academia joint projects. The first one we started in 2006, 20 years ago. It was a project initiated by Ericsson Hungary, and this was about analysis and refactoring of Erlang programs. Why is it important? What kind of impact it may have? You should know that 90% of the internet traffic is carried by devices using Erlang programming language, and we are asked to work with that functional programming language. It was set in an international environment. We have cooperation and had cooperation with Kent, St. Andrews, and other universities and companies as well, not just with Ericsson. And the result of this project is that we have successful doctoral thesis defenses, 4 of them, and we have more than 100 papers published with a lot of citations. So all the results are well known, and Ericsson offered us the possibility to publish even the source code of the software tool we produced in an open source way, so it's all the results can be used by everybody around the world. So it's really very encouraging that if you see that your results are useful for many people and all around the world, and you get feedbacks of that. The next one I would like to mention are about networks, the programmable networks, 5G networks probably you have heard about, or 6G networks. It's about to control the network traffic, or about to control robot arms using devices like switches, where the switch and the robot arm are close to each other, and there are low latencies and very new possibilities to implement your ideas using these tools. We are proud of that. Our research team was successful in European grant applications, and we ran several Horizon Europe projects, and we received grants for it. The next topic I can use as an example are about self-driving cars, or how to support drivers. And what I should mention is a cooperation with Bosch, and we have a department, we are currently at the department AI, which is supported by Bosch, and this department is working on solutions, how we can identify, understand traffic situation, how we can process signals coming from LiDAR, radar, and usual cameras, how to do the fusion of that kind of signals. And again, we have several PhD students successfully defended in these topics. If you are driving, you have to take into account the surface of the road. We have a project which is about smart tires. This is about sensors which are built into the tires. This is a patent, and you can identify the situation, how safe is driving in rain or among other circumstances. One of our most important topic is human-centered artificial intelligence. We had several projects on that, like how to deal with smart factories where big machines and engineers are present at the same time, how to identify dangerous situations, how to take care of the humans among big machines, and the other projects like where you help, for example, young children who have some disabilities, developing some software tools in a way that they are learning by playing, and they are getting skills to compensate their disabilities. And a similar project we had earlier at the time of the COVID, when we have supported people in rehabilitation processes, when the only way to run rehabilitation treatment was via internet. So these are just a few of that kind of examples. We have also cooperation in medical image processing, where the goal is to decrease the radiation level, but at the same time to increase the quality of the images. This is not easy. If you decrease the radiation level, then you have problems with the quality. But there are nice solutions we offered for CT, MRI, and other devices in cooperation with a company. We have also some interdisciplinary projects with our faculties, like Faculty of Humanities or Faculty of for special needs, and such projects are at the topic of digital humanities. For example, we had the project earlier to process Old Greek text, for example. One of the most famous project of us is the Code Checker, Code Compass project, in which we have developed software tools to understand source code. Software understands software. This is the code comprehension issue. And there are many companies using this set of tools, like, of course, Ericsson, who ran this project in cooperation with us, but also Intel, Google, Apple, and many others. So we get feedbacks from all over the world, from the users of this set of tools. And for example, Firefox code is checked by Code Checker, and we have already 7 PhD students who has defended their PhD thesis related to these research topics, and more than 300 independent citations for the papers where we have published these scientific results on which our software tools are based. So probably these are the main examples I can share with you, but we have invited representatives of our industrial partners, so they will tell you what is the most useful from their point of view. And I have also invited some PhD students of us who can share their experiences with you, why they are motivated to go ahead with their research topics. Some of them are related to the topics I mentioned, some of them are different from these ones. As a conclusion, I can tell you that the PhD studies is about that you get the ability to create new knowledge beyond the state of the art. That's very important because of it's different from even from master studies, that getting the skill that you can solve challenges which are open, and your results have an impact for the whole world. That's a very important new way of study and how you get experience. And of course, we expect that all this knowledge you produce will be published, will be public, in a way that you publish conference and journal papers at the right quality. Being member of a team and doing teamwork, you get soft skills, including leadership experience. You work together with, very often with a group of master students as well. The impact you can produce includes patents, open source licensing, and many other kind of industrial applications. Your results became public good, and probably you will introduce new business models, and even more you can study a little bit about how to make business. We offer courses like this as well, and you can start your own company as well using the knowledge you learn here with us. I would like to emphasize that we are in an international context. We run strong international cooperation, and we have a high international visibility. So our research is embedded in industrial and social environment, and we have the experience that we have an impact on the world, producing our results by you. And now I would like to invite the first speaker. The first speaker will be the representative of Bosch, one of our key industrial partners, Tamás Fischl, and he will tell you what is important in PhD research from point of view of Bosch. Tamás, please.
Okay. Thank you for the opportunity.
Okay.
Thank you for the invitation, and thank you for having me here in this Open PhD Open Day event. As Mr. Professor Zoltán Horváth mentioned, we have in ELTE several industrial cooperation. I representative for the Bosch ELTE cooperation, which is with ELTE together, Bosch founded in 2020. In this time we have an increasing number of activities on this field, And I would like to give you an overview what kind of opportunity we have in collaboration with Bosch, how you can contribute to such projects, what kind of topics we have, give a short overview, some examples, for us in the next 8 minutes. Yes, shortly, what's about Bosch? Bosch Hungary is near to ELTE in Budapest, and we are active in automotive industry, so mobility industry. But we have also plants. We're also producing the results or the products which we are developing in the Engineering Center Budapest. I am also from Engineering Center Budapest. I'm in one role. I am a developer in the Engineering Center Budapest. In the other leg, I'm sitting also in ELTE and collaborate with the ELTE colleagues together and finding new projects, identifying those activities, which is very interesting for the industry, and also it can be very interesting for the research topic as well. So it's also the collaboration basis that if you start with us, basically to cooperate, then we are providing such topics which you can also using for the research. You can actively publish on that, and on the other side, you can also make patents out of that, as the professor also mentioned, or we can make final implementation. So actively, those things what you research basically will be a real application in the field. It can be also in a development or in the production as well. What means a research topic, how this collaboration you can imagine if you start such a topic, it means that you are working on a research topic which will be results will be a development topic what you can use for product development, or later you can make a activity, an algorithm, for example, in AI topics, which could be also a part of the production improvement in case of accuracy or internal defect cost reduction. So basically productivity increasing topics what we are working out with the AI department. And normally in this cooperation you have two supervisors, typically one from ELTE and one from Bosch. The two supervisors is a guarantee for that these two goals basically that you need to have research papers, and we take care that we can thematize the development, get the right direction, and we take care that the research is a current topic, a state-of-the-art topic which we have the possibility to implement in the industry, but other side you get out quality papers for research as well, and finally you can defend your thesis successfully. As Professor mentioned, we have some good examples how it works. In 8 minutes I do not have the time to get a complete overview of the topics, only a summary that we have. In the meantime, for example, in 2025 we have 9 new PhD students in the collaboration with the ELTE AI department, and we have 75 scientific articles only in the last year, and the patents, over 20 patents, which is basically the results of the PhD students, MSc students who are working in this collaboration. And Mr. Professor also mentioned the interior sensing and autonomous driving. This is typically the topics that we are working on the Engineering Center Budapest. But on the other side, as you can see on the slide, we are working also industrial technology, AI and robotic collaborations, or anomaly detection, process flow optimization, machine vision. Typically, those topics which are relevant for productivity increasing in the plants. But we are also proud of the topics that we can support, topics like basic research topics. If you heard about the spiking neural networks, basically technology which definitely in the next 5 years will be not implemented in the industry. So it's basically a basic research. In the meantime, we have the industrial supplier who provide us, for example, this technology, and we are able to try out those technology in the real time as well. So this pictogram shortly provide an overview. This is over 30 different topics in the last 5 years that we identified. It's not only PhD students, it can be also MSc students, it can be also different collaboration with ELTE, larger R&Ds as well. So if you are interested in, then contact us and we can explain more. Hopefully you can also join such technologies. Only one example is, for example, the AI and robotic technologies. This is one of the flagship that we worked out in the last 5 years. I need to explain a little bit more about this technology, what it's about. So the heart of every technology in Bosch is basically an electronic device which has a PCB, a printed circuit board, and some elements on it. And you can see on the slide on the bottom left, if you open the slides, that basically on the logistics side, we get some PCBs and elements in a package format in the logistics side of the plant. And on 24/7, basically, colleagues manually open these boxes and unpack these goods, basically to store in the production before it's used up. So it's a manual process, and also the target for this technology was to automatize. This is typically a topic which you can use AI for that. And the idea was, we've worked on more than 3 years on that to identify all the items that we need for the unpacking process. You can imagine that it's cutting, identify the boxes, cutting the boxes, open the boxes, identify the goods. And only if you have 30 seconds to show the results of this activity, then you show you the video what you can open also on the slide, which means that one element of this unpacking process is what you can see is the demo which is realized at ELTE with ELTE contribution. Also several patents are, more than 10 patents will generated about that. What you can see here is the recognition process where we have a camera system mounted on the robotic arm. It will be identified one by one the goods in the boxes and unpack it. So basically the question was, are we able to develop an AI process, an algorithm to detect these boxes, these goods, and are we able to separate that? This is one element of the unpacking process. Of course, I can tell you more in hours. We have no the time to explain what different backgrounds we need for the successful realization of this project. Another example is again on the plant side. Again, this is a so-called process flow optimization. This also includes several projects. What we actually working on is an interesting, and I found the video for that which I would like to share with you as a very actual current topic. It's basically, the background is that we have lines in the production. We have production lines where we build up different products. In the meantime, it's not a secret that because we have changing of the production numbers, and also we have ramp ups and ramp downs of different products. It means the expectation of the customer that we produce every time basically everything. Of course, it's not possible, so we have to change the product, the part numbers on the production side. For that, we need flexible lines. Flexible lines means we need to be able to change the product time to time and be effective on the production side. For that, you can imagine there's an algorithm behind them, how we can build a line, which is the structure, how many people do we need for that, which part numbers, how many parts do we need to build up. So it's not a single rule-based solution what we have. So the human thinking is not enough for that. So basically, we developed an algorithm which optimizes the line for us. The structure optimization of the line is there, and basically determine for us how many products we can build up on this phase, which human resource we need for that, how many maintenance time we need that, which is the open and close time basically for this production. And one video what you can see how this production line is working. This is the two level lines what you have here, and basically we need to determine how many of these boxes, how many of these products we need to send out. In every of these gray boxes are elements with different functions, and basically these two steps you can see in different loops the working the production, and basically the optimization of this process is basically also which is working with the process flow optimization. We use the evolution algorithm is also a very special algorithm for the AI architecture. And so this is one project where we also can step in if you want to join to our research topic. And my time is over, so I thank you for the time, and I hopefully we meet you with ELTE. Yeah.
Okay, thank you very much.
Thank you.
Thank you, Tamás. And I would like to encourage you to click on the presentation. You can do that, and even to watch the videos. And I also would like to encourage you to send questions to us. And we have the first question already. The first question asks whether computer science background is necessary or obligatory to start a PhD school in informatics or not. It's not obligatory, but of course if you have a research topic in theoretical computer science or in a given very strongly computer science based research topic you have, then it's necessary. If you have an interdisciplinary research topic, that you may start the PhD school having a different master degree as well, and then you can catch up the necessary courses, choose the right ones, select the right one from our master programs, and then you will do your research in such a way. Now I would like to invite our next speaker, Smiljana, a PhD student, and she will share with her experience with you.
Hello, thank you for inviting me. So my name is Smiljana Knezev. I come from Serbia. I'm a third-year PhD student of computer sciences here at ELTE. So I am part of the Refactor Earl team, which means that I am doing static code analysis for Erlang and Elixir. My supervisor is Professor Todd Melinda, and so my research has to do with finding security vulnerabilities in the mentioned programs. You might have not heard of Erlang and Elixir, but you have probably heard of applications such as WhatsApp, Pinterest, Discord, and so on. And Cisco also uses Erlang, so as Professor Zoltán Horváth mentioned, so 90% of internet traffic goes to Erlang nodes. And when such systems fail due to a vulnerability issue, it really has a big impact. And as mentioned, so PhD studies are a lot about publishing. So my journey has taken me all over the Europe, in Brussels, Belgium, in Prague, in Czech Republic, in Slovakia, and so on. So at conferences, at summer school, etc. So what is important to mention here is usually when you reach at that level, you already have either a poster or a paper, a publication. And what is really a strong advantage of this doctoral school is that your conference fees are covered. So you don't have to pay it yourself, and this is not the case with all doctoral schools. So this is a huge advantage. Also, so my research topic is connected, and the research team is connected with industry, so they cooperate with Ericsson, Erlang Solutions, and so on. And through a special scholarship program called Cooperative Doctoral Program, KDP, a Hungarian state finance program. Since September, I am working with Erlang Solutions, and I get to integrate my research into a tool that is actually being used, a tool called SAFE, and then again I can use that tool to produce further results that can be published. So the tool is free for open source projects. So I'm working part-time at Erlang Solutions, and the rest I am here at the faculty. And there is always that internal question, so should you choose academia or should you choose industry? But in this way, you can have a taste of both worlds. So why not both? You can choose a research topic that has to do with industry, and there are a lot of research teams, so not just for Refactor, all over the faculty and different departments that have strong connections with industry. And there are many opportunities. There are different scholarship programs, so it's not just the KDP, there are many other. And other advantages of this doctoral school is that you really get all the resources and all the support you need in your professional development and in your research. So you get access to the equipment that you need. You can get computers, monitors, whatever you need. You get your office space. Again, these are some of the advantages not all doctoral schools necessarily offer. And all across, so there are many good research teams, and I advise you, if you're interested, to reach out. So to doctoral school, to the professor, to the team, and look for information. I think you can find, and I'm very happy with this program, which is why I'm here talking.
Anna, thank you very much. And yeah. And we will answer the questions you sent at the end of the program. Yeah, and so now we continue with a supervisor, a successful supervisor with Márta Turcsányi. Márta, the floor is yours. Yeah, you are not alone, as I see.
Interested. I would like to talk about the research topic that we are dealing with, AI in education, especially higher education, but not necessarily just higher education. So, what are the facts? The Gallup Institute has recognized a lot of facts about students, mainly that they are using AI in their studies. For what they are using, their especially understanding, and marginally also for development. But what is most important in this is you have to understand how this is taking part. Now, in my presentation, I would like to talk about the research that we are doing, which is AI-powered research. What we're not going to talk about is what AI research and development is, since it is taken part in the AI department. What we are going to research is the effective use in the teaching process and in the learning process, especially assessment in computer science using AI, and also how to integrate artificial intelligence in scientific research. Marginally, we are taking into consideration what is AI literacy. So in this process, there should be some scientific background on computer science or a pedagogy or methodology, as we are also trying to involve students who are teaching in school or in higher education. So where does my assistant come into process, Maya? She's assistant professor, and she's also taking part in the classes of the therapy dog. And also, since we're dealing with teacher education and also researching with children as well, she's taking part in the children's understanding of AI and how to develop. So one of the main issues is the effective teaching and assessment in computer science using AI. What would those mean? How can you use and develop technologies, AI technologies, that it would help in the personalizing process or the scaffolding of students? Or how to redesign the assessment and what tools could help with this? How to develop and cultivate critical thinking. Also, what kind of knowledge management tools could help the students in the learning process. Mainly and mostly the transparency process and the ethical reflection is always very important in this process. So how about the effective, what would be the methodologies that we are using? In personalized learning, it's the zone of proximal development. So some of the methodology tools you will have to encounter, especially if you have a little pedagogical background. How can AI be used in the hybrid collaboration process and in the program development process or problem-based learning? And of course, especially in the assessment, and what kind of assessment tools could be developed, or raising the literacy rate. So our students are developing and trying to research the effectiveness of these tools in the learning process. Of course, especially in higher education, it's in the computer science. But since we're dealing with teacher education, I can say that in any other topic as well. In teacher education, we also have a possibility of bringing students into our labs, whole classes, and trying out the tools and the methodologies developed to see how effective they could assist in the learning process. Of course, we are trying to redesign the assessment so as to raise higher order thinking skills, and by this we're trying to see how the AI can help in authentic assessment and also in increasing the reflective process and the metacognition of students, which is highly appreciated at this point. In the research process, it's very important to somehow integrate artificial intelligence, as it is raising the speed of your research. But of course, you first have to base your ethic foundations and some AI literacy to do that. Prompt engineering is necessary, but it's easy to understand and study. And of course, you will always have to work very transparently. So the first course in the research, in your research, will be research methodology, which will show you the research paradigms and how AI is activating and more as like a catalyst in scientific discovery. How it's going to be much more quicker to use these tools, but ethically. How it will, how this kind of human AI process can enhance your research, but of course also seeing what are the risks and how you can still maintain academic integrity. Of course, we have laid down the policies of using AI, but nevertheless, you will be looking throughout the research process to see what the ethical foundations are, how you can use it in conceptualizing, in your literature review, research design and methodology, of course in data analysis, drafting and writing, but not to mention the fact that the reflective process will be your most important process in this consideration, as ethical considerations are very grave in the scientific world. You have to be transparent and accountable. You have to be responsive to your data management with whom you are making the research. You have to ask for informed consent and, of course, minimize harm to human beings. And equity and inclusion is, of course, very important in this.
And before the next talk, I was asked to answer a few questions. The next question we got, what is the tuition fee for students? The tuition fee is 4,500 euro per semester if you are not granted in a way. But even if you are not granted and you have to pay a tuition fee, you may join an industry university project lab, as we mentioned, as many of our PhD students. And all the money we get from the companies are used for giving research fellowship for the PhD students. So this is the tuition fee in that sense may be compensated if you get such a research fellowship, if you do successful research in a project industry university research lab. Or there is another question about teaching, whether it's mandatory or not. It's not mandatory, but you know you have to collect credits, 240. And among the credits you collect, there are so-called teaching credits. So if you give a course, you get credits, and you can use it in your studies, and you get very nice skills if you teach. Moreover, you get also some money for it, because we pay for you if you give lectures for master students or for bachelor students. Okay, these were the next two questions I wanted to answer, and then we will continue answering the questions later on. However, now I ask our next PhD student to share her experience with you. Georgina is the next one.
All right, thank you. My name is Asuah Georgina, and I am from Ghana, and I am a third-year PhD student with the Faculty of Informatics, and specifically, as already specified by Professor Zoltán, I am with the Data Science and Information Systems section. So my research more or less revolves around information systems and then data analytics specifically. And I'll briefly talk about what my research revolves around. My research entails the optimization of machine learning and artificial intelligence integration in enterprise resource planning systems. And literally what enterprise resource planning systems do is they form like the integral or the core part of organizations where they function by collaborating and taking care of the interaction of supply chain management when it comes to production. And as already demonstrated by the representative from Bosch, he demonstrated how they have used AI and machine learning in their operation, in the unpacking of these items. So my research mainly looks at how we can optimize machine learning and AI integration in these systems. The reality is machine learning and AI is evolving really quickly and very fast. However, these systems or ERP systems haven't or were not necessarily developed to adapt to this kind of change. So how do we catch up with the level of change that's happening in AI and machine learning to integrate it into these systems that were not necessarily developed to adapt to these changes and evolution that is happening? So that is where I found the gap or the kind of motivation that I got that led me to this point. And so far, what I have been able to do with the guidance of my department, the faculty, and my supervisor, Tamás, we were able to come up with a way where we can integrate machine learning and AI through APIs. So we developed a pipeline where we are able to detect anomalies in operations. When operation data is analyzed and the anomalies that were detected, we developed a pipeline where we were able to use API to be able to process this flow, where we can adapt to the new technologies and machine learning advancement and take it to the advantages of these systems. One other key thing I will talk about in terms of this aspect is the way the department and then the faculty I work with have been helping me and my whole PhD journey. One thing is the teaching aspect, where it gives me the opportunity to share my knowledge and my experience in this research and this area with master's students as well as bachelor students. And the opportunity it also gives from my department is that you get to work with master's students. And this opportunity actually led me to do a work that is relevant to my thesis or my topic as well as being relevant to the industry. Currently, I worked with a master's student who had this collaboration with Finland. She started in ELTE but had to complete her studies in Finland, and we got to work with a company where we had to develop a system for them to detect. It's a gaming company. They are able to detect if gamers have paused or not played for some time and if they are about to churn, and then the type of offers they can make to these gamers. And then the architecture we developed, the pipeline we developed, the company actually adopted it, and then they are putting it into use. And that has been, that was a realization for me through the help and then the opportunities provided by the school that I am with. One other thing I'll talk about is the fact that they offer resources, the university offer resources, or the faculty offer resources in terms of machines. I have personally used computers that have been provided by the faculty to help me in my research process. CPUs that are needed in terms of my aspect, they are provided by the faculty and then the department to help me in my research journey. And then I can also talk about the fact that it doesn't all end at the academic level. With the department I come from, we organize social events that help us go beyond just the academics to actually interact with each other, have a life, and socialize beyond just being within the confines of academic, but rather also have a life that is sociable, or a social life beyond the academics. And that is very important or useful for the life of a PhD student, because yes, the reality is it is not easy and it can get really stressful, but then there is the help and support for you to have a social life and also even interact with psychologists if the need be. I would also just want to touch on the fact that it's not just only conferences that the faculty covers. When you want to attend, they pay for everything. But also they offer the opportunity to publish your work via journals, where they provide the journal subscription. So when you are able to do your work properly and then you want to publish in reputable journals, the fees are being paid for because the faculty or the uni have these subscriptions that provide these opportunities to publish your work. And based on that, I have taken opportunity, or I've taken advantage of this opportunity and also published my work in journals as well as attending conferences to communicate my work and then make my work that I do also visible out there. Thank you.
Thank you very much, Georgina. And before calling the next speaker, I again answer one of the questions. The question was about whether is it necessary to be here in person, or you can do it in a remote way, your PhD studies. The answer is that we ask you to be here in person, both your study and research. And why is it so? Georgina has answered it, I think, just a few seconds ago, that it's very important to become a member of a team and a community of the PhD students and researchers. That makes a big difference. So we welcome you here at Budapest. It's a beautiful city, is it? Yeah, thank you. And the living cost is not that high at all. It's a relative cheap living cost you have to take into account. And as I mentioned, you can apply for research fellowship coming from industrial partners and so on. So that's a working model for you being here in presence. Our next speaker is from Ericsson, István Gódor. István, the floor is yours. Thank you.
Very welcome everyone, and I'm thanking the invitation. To be, and I can be here and also present our research cooperations. As you know, there are quite some large companies with R&D centers in Hungary, and beside Bosch, Ericsson is one of those top companies, and such that we have quite deep and long-term cooperation with the universities. And let me briefly introduce that what kind of community you can join as a PhD student. So for example, just in Hungary, we have quite large, roughly 2,000 people in our R&D organization. From that, 1,600 working dedicatedly on the R&D stuff and 400 for regional market and global services solutions. And as you can see from 1,600 people, so there are quite many topics where you might join. And let me give you a few introductions. You can see from the image that we are actually in the next building to ELTE. Oops, sorry. And within that, I would like to highlight that our community is quite innovative, and we invite the universities in these cooperations. So in our R&D, we have more than 500 granted patents until now, and we have about 30 or even more together with ELTE in our cooperations. So we can open up such topics that can be relevant also in IP creation, also in standardization. So it goes beyond the traditional industrial cooperation. And I would also highlight that we had quite many employees with PhD degrees, and all of them are coming from our university cooperations, quite large amount coming from the ELTE University, especially in the research and some technical leadership positions. So it's really nice to see. I will give you some examples that what kind of topics they were worked on, especially on those who are working quite closely together. And when joining us, then it's even more than the industrial community, but you can be involved in the local ecosystem as well in quite many aspects. Naturally, we also work together with the Hungarian Academy of Sciences and the related research networks, and also together with quite some technology specialist communities like the Scientific Association for Info Communication, the Association Together for Engineering for the Future, Hungarian Innovation Association, and so many. So you can join this community as well via the cooperations between the industrial partners and the university. And of course, we have multilateral cooperations. So there are neighboring topics for example, in BMA or in the Hungarian Research Network, and you can work together. And there are really good examples that some theoretical or analytical knowledge are coming from one university within other university. You can work together, can write such top papers that could get even thousands of citations, so you can get into such a community where are the top people in Hungary as well. And of course, if you joining industrial cooperations, your results will be presented within the companies, and you can reach to the top guys defining, for example, in our case, the mobile communication started with 30 years ago, and you can find the best people there. Yes, regarding the patents, so both Ericsson and Bosch, we are the top leaders in Hungary in creating patents, so you are in the really good place today, so you can be involved in that side, the top research. And as it was mentioned by Professor Zoltán Horváth, that we have two laboratories at the university. One is called the Software Lab, and we have a communication lab as well. So I would like to highlight a bit what we are doing here. And in both labs we had quite long cooperations. I couldn't go into the details, but if you are interested, you can reach me. The Software Lab, it's a quite long cooperation already. It's more than 15 years old, almost 20 if we comparing or starting with the professors comparing it. It was mentioned that Melinda Toth is the main contact and leader of this laboratory, and we have many topics already highlighted by Zoltán, that we have the software analysis, verification, different type of optimizations, and now even though that we have static code analysis like Code Checker and Code Compass and Refactoria, we know about the future, so some kind of LLM-based code analysis, when you can even have mixed type of coding in the background. So that kind of analysis are also very important. And I can tell that yes, Erlang is a quite important programming languages, but when I was a student, if you can write an Erlang problem, it's more than sure that it was okay if you can compile it, because it's you cannot do tricks that can kill the programs, especially nowadays when many use AI for that. That kind of bugs could pop up, and that kind of software analysis is more and more important. And the time is running, so let me give some examples. Within this laboratory, we have more than 16 defenses. Maybe today it's maybe closer to 20, so quite much. We have many publications together, and that it was highlighted with many internationally used products. So I step a bit further to give time to present also the networking part. As I mentioned, there are two topics that can be found: software research and also networking research at Doctoral school. And from that, let me give you some examples. So programmable networking, that was also mentioned in one of the examples, that to do some engineering already within the network and not going to faraway server farms. We are also working together with Industry 4.0 applications, also with robotics. We can have in-network computing applications, point clouds, AI aspects like explainable graph neural networks. So you can find various topics that you can join here. And also with this laboratory we have quite many PhD students. So altogether we have 40 plus PhD students finishes in the cooperations with the company. I think it's really nice. And we can mention that you can have so many topics, and we can always find, as you will work together with researchers, we are also our aim, not just having company codes, but also thinking about the future, the new architectures of the upcoming internet or mobile networks. So we're also interested in to have scientific publications as well. So if you join such a community, you can get it. So it wouldn't be a problem that, oh, okay, how can I get scientific credits for my work? And you can. And I can assure that in an industrial cooperations, maybe the visibility could be bigger, because there are already quite much interest if it's coming out from such large company. And as a closing verse, just few PhDs that are, some of them work out, some of them choose the academics. So, for example, we started 15 years ago with, for example, network measurement observatory solutions. We have also used traffic analysis, for example, for land use detection, and also kind of predictions of local activity patterns of the users. You have to fine-tune the networks for that. We have network quality, scalable network quality, for example, focusing on hierarchical QoS in the networks. And even we have quantum annealing and machine learning for telecom applied. So if you have any questions, you can reach out to me, and thank you very much for your attention.
István, thank you very much. And this is really our cooperation, which was started as the first one with you, and a lot of results we have jointly with you. There are a few questions again. Whether the cooperative doctoral scholarship is compatible with Stipendium Hungaricum? No, this is not either or. So, but it's available, but not with Stipendium Hungaricum. The other next question is, how does the application process look like? I think you should contact our staff, and there is an email address. I hope it's shared now. The email address is phd@inf.elte.hu, and you get information package about how you should apply, what to submit, and you will get also support to find research topic, project, and supervisor as well, if you send us a motivation letter about your research interest. So, and next we will have a talk again. Tamás Tófalvi, Tamás, please. A PhD student of us will share his experience. He's in, machine vision, or something. Yeah, please.
Okay, hi. I'm Tamás, and I'm here to talk a little bit about my PhD journey. During my master's studies, my favorite subject was computer vision, and through that subject, I was given the opportunity to join in the work of the geometric computer vision group and participate in the work that they do. And through that, I managed to do a TDK, which is a national conference for bachelor's and master's students. And I even managed to have an international publication, and I found out that I really like this whole research thing, and that naturally led to starting a PhD. My main topic is in sensor fusion and perception and sensor calibration. What do I mean by sensor calibration? Well, most of you probably know that every autonomous system, from basic robots to self-driving cars, usually has more than one sensor on it. We can think about quite a few cameras, or LiDARs, or radars, or ultrasonic sensors, or IMUs, and stuff like that. And all these sensors give their data in their own coordinate systems. And if we want to use the data together, we have to find the transformation between the different coordinate systems of these different sensors, and this is what we call sensor calibration. And we can talk about target-based sensor calibration, where we have some kind of object that we know the geometry of, and given some measurements with multiple sensors, we can extract the geometric information from this calibration target and calculate the transformation between the sensors. And I have, for example, a paper on LiDAR calibration, where we use a kind of cylinder and measure the cylinder. And given that we know the shape of this cylinder, we can find its principal axis, and from that we can calculate the transformation between multiple LiDARs. Or we can talk about targetless calibrations, where we do not assume anything about the world, and we want to solve for the sensor poses without prior knowledge. And most neural networks or most deep learning methods fall in this category. And I have a current research project in this kind of calibration as well. We are trying to do LiDAR camera calibration by taking the camera image and lifting it into 3D through monocular depth estimation. And then we have a 3D point cloud from the image, and we have a 3D point cloud from the LiDAR, and we are trying to solve the calibration problem in 3D by point registration, basically. I was quite lucky here at ELTE and at the Geometry Computer Vision group, because we have quite a lot of sensors already available to us. So we have a lot of cameras, we have a lot of LiDARs, 2D LiDARs, we have IMUs, we have GPS trackers, and so on and so on. And we also have the ELTE car, which means we can put these sensors on a vehicle and then go out into the streets and take measurements. And that gives us quite a lot of flexibility, because we are not dependent on public data sets and so on. And this is quite unique to ELTE, to be able to have a street legal car with LiDARs on it. Also, I just want to mention that, yeah, we are quite lucky here, because we are encouraged to publish at high quality conferences, and the university supports us in attending these conferences. So as a PhD student, you have the ability to travel and see the world and meet new people and meet new researchers and share your ideas around the world, or even gather some insight from other people. Yeah, I don't know. I found out during my PhD studies that I like teaching as well, so give it a try. And overall, I'm at my last year. Hopefully, I will defend soon. And the whole PhD was a very positive experience for me, and I will probably continue my journey on academia. Yeah, so I encourage you to, if you are, especially if you are a first-year master's student now, that try yourself during your master's studies and try to join in the research of some research group here at the university, and do a TDK and just get a taste of what this is like, because I don't think there are a lot of jobs out there which gives you the kind of freedom as being a researcher can give you.
Thank you, Tamás. And before we continue, I try to answer a question again. The question is about the first 2 years. What is the program for the first 2 years? How many courses you have to take? The answer is that you have to take 1 course per semester in average. So four courses are the minimum number of courses you have to take. You can take more if you need more knowledge, but we focus on research. So actually, you should choose courses which you need in your research topic. This is the idea, and that's why we don't ask you to take too many courses, because of you need the courses you are really necessary for you. 1 course is obligatory. This is research methodology. This is obligatory for everybody. This is one of the minimum 4 you need to take. And because of the complex exam, the comprehensive exam at the end of the first 2 years, where there are 2 topics, you have to do the exam of these 2 topics, you are asked to choose at least 1 course related to the one of the topic you have chosen for the complex exam. And the other 2 courses you can choose as you like, or as your supervisor is asking you to, because of your supervisor is your boss. And then he or she will tell you which course to take. So, and is it possible to work part-time during the first half or during the second half of your studies? Yes. However, find a job which is related to your research. Otherwise, you will be in trouble. Yeah, I know you can work 160 some hours per week, but it's not easy. So to take a job which is related to your research at a company, probably at the same company we are running a project, and you are a member of the project in the cooperation with that company, is a clever decision. Or you take a job at the university, this is also possible, and then do your job at the university is maybe also related with your research. So these are good choices, but if you do something completely different, then that makes difficulties. Yes, probably we continue now with a PhD student again, with Aya. She comes and shares experience with you.
Okay, hello everyone. My name is Khedda. I'm a second-year PhD student at the Faculty of Informatics. I'm from the Department of Computer Algebra. I am originally from Algeria, and I came here through the Stipendium Hungaricum scholarship. Today I want to talk about 4 key points. The first one is I will explain my research topic and what I'm doing currently at ELTE. The second point is the type of support you might be getting from the faculty or from the university in general. Also, what are the type of opportunities that might come across your way during your PhD? And lastly, I want to touch upon my experience as an international student in Hungary. So my research topic is security in federated learning systems. In case you don't know what are federated learning or what is federated learning, it's a distributed machine learning approach that allows multiple parties to jointly train a model without sharing their data sets. So in traditional machine learning or traditional centralized machine learning, what happens is that we have a bunch of clients. These clients send their data sets to a server, and the training happens at the level of the server. But in federated learning, which was created by Google in 2016, these clients keep their data sets locally, and they even perform the training locally. And instead of transferring their data sets, they simply transfer model updates, which can be either gradients or their model weights. In this case, the server only aggregates these model updates to form the global model, and then it sends it back to the clients in order to start the next training round. Okay, so the first intuition when we hear that our data sets are kept locally and not sent to an external server, for example, is that federated learning is secure. But actually, this is not the case. In 2019, a group of researchers came up with an attack that is called deep leakage from gradients. This attack allows an adversary or a malicious actor to actually reconstruct our data set just from the gradients or from the weights. And this is not the only security issue here. There are many other types of attacks. So we don't only have privacy attacks, we can have poisoning attacks, which aim to degrade our utility of the model. There are also backdoor attacks, which intend to insert a certain behavior in the model. There are also free-riding attacks. For example, we can have a client that is participating or pretending to be participating in the training, but it is just, for example, sending random numbers as its weights. Okay? But it can be receiving rewards, and this is where the risk comes from. So what is my role, or what am I focusing on in my research for now, is developing and implementing and designing some solutions for these systems. My work basically depends on cryptography. I use things like multi-party computation, homomorphic encryption, but there are other defense mechanisms like blockchain. We can use MTD, or moving target defense. We can use differential privacy and even other machine learning techniques. The second thing I want to talk about, like I said, is the type of support you might be receiving from the faculty or the department. The first one is the PhD classes. As you know, there are a variety of PhD classes that you can take at the faculty. You don't have to necessarily just apply for 4 classes. You can take more depending on your research topic. The second one is, like my colleagues have mentioned, we have multiple devices that we can use. In my case, I prefer using, for example, the servers provided by the faculty, because I need to test the scalability of the solutions I create, and I need a lot of computation power, especially when cryptography is involved. The third one is financing. So you not only get the costs covered for your publications and for attending conferences, but also you might get some costs covered for attending events like workshops or summer schools. The third point I want to talk about is the opportunities that you come across during your PhD. The first one is collaborations with universities. So you do not only have to work with research teams at your own department or the same university, but you can work with universities from outside Hungary. For example, in the previous semester, I had a collaboration with Asuah University from Switzerland. And the second one is projects. For example, right now we are working on the network project, which is a big project that involves 14 countries, and it is on the security of 5G and 6G networks. And of course, we have some contributions regarding federated learning. The last one is scholarships. Actually, ELTE has a scholarship. And not only that, but you can also get Erasmus Plus to study a fully covered semester abroad, so not solely in Hungary. The last point, which is experience as an international student. So I thought I might have some issues with the language since I don't speak Hungarian, but actually I had none. I was performing my PhD in English with ease, and even I can communicate outside with people in English as well. The second one is that Budapest is a beautiful and safe city, so I recommend at least visiting it. And your residence permit allows you to visit other countries as well, so this is another plus. And finally, Budapest is a big city, which makes it a hub for national and international events. So if you are interested in these, this is a good opportunity. Thank you.
Thank you very much, Aya. And Aya is from the Department of Data Science. Am I right, Aya? Computer algebra, okay. I just wanted to mention that we have also a second industrial department, the data science one, and the data science department was established by Deutsche Telekom, T-Labs, Innovation Laboratory T-Labs from Berlin. So just another example you may be interested in to join in data science topic. I have some more questions. Probably even more we will receive meantime. So now I start to answer the questions. The first question I have now on the top of the list is how are applicants evaluated? Applicants are evaluated based on their research plan, research topic, how well it's defined, because of we have the experience, if you have a good research question, a clear one, then you will be more successful compared to the situation if you are spending your first semester just identifying your research question. So be prepared. That's very important. By the way, there is deliverable for at the end of the first semester that you have to submit a very detailed research plan compared to the original one, which one you submit at time of the application. So this is the way how we work with you. And another aspect, other indicator in the evaluation, how high quality of results you had at the time of your master studies. So we evaluate your degree, your results coming from the master program as well, how excellent you was. And there is an other question whether a prior research experience is expected, not, but of course we take into account. So if you have a research experience already, and there is another question whether publications are required for admission, no, but we take into account. So if you have already papers published, then you have better chances, of course, compared to other applicants. How can I be part of a research team? So you should write a research topic related to the research area of that research team, and then you can join it. And of course, if your supervisor is the head of the research team, then you will be invited to be a member of that research team. And of course, if the research team is cooperating with an industry partner, that you are getting in touch with the industrial partner as well. Can I stay teaching at the university after my PhD? Yes, it happens often that we invite you. Yes, we invite you already at the time of your PhD studies to join other teaching staff as an assistant, as you have heard. And we welcome you to join us as an assistant lecturer at the end of your PhD studies. Typically in the 5th year of your PhD program, when the study years are completed already, but your thesis is not completed yet, for that 1 year, very often we offer you a teaching assistant, research assistant position as well. And we have already colleagues at the level of associate professor who has been earlier master student of us, international students of us as our master programs. And then they have completed their master studies at us. They had continued PhD program at us. And now they reached the level of associate professor, and probably they are trying to be full professor soon. So there is a full academic career open for you if you are motivated. Is there a maximum duration for PhD studies? Yes. But it's tricky to tell how many years, because of you may insert so-called passive semesters, or you may ask for some break because of some family reasons or anything like that. So, but if you are just counting the active semesters, that the general rule is that you have 5 years, 4 years in the study period, and plus 1 year for submitting the thesis. You may ask for a one more year, and in total you have 6 years to complete your studies, including writing the PhD thesis. Is there any accommodation for PhD students or some kind of dormitory? Yes, the university has dormitories, but to tell the truth, there are limited number of places available, especially for PhD students. That's not that easy to get a place in a dormitory. Probably for the first year, you have a good chance. So the policy that first-year students get a place because of it's hard to find the accommodation where you are coming from far away. But when you are already here and you became second-year students, you have time enough to find appropriate accommodation for you. It's not that expensive to rent a flat in a team of your fellow students. So it's very typical that 3 students or 4 students are renting a flat, but probably even you yourself alone can rent a flat very often. It's not that expensive to do. Dormitory places are limited, again, I have to tell you. I don't see, I try to refresh my screen. Yeah, not easy. So probably you have to read the questions because of my screen does not want to, no. Yeah. How many publications are required for PhD degree? It's hard to answer this question. There is a minimum of 2 high prestige publications. So journal papers of Q2, Q1, conference paper of A star B, you need at least 2. But typically, this is not enough. Typically, you have 6, 7, even more publications at the end. Not all of them are at the same quality or same prestige level, but you will have about 6, 7 publications, typically at least. Yeah, any more question? I should refresh my screen again. I don't see the latest questions, but probably my colleagues can read the questions. And you can make a research on latency.
How to have information about the research team topics?
Just browse our web pages. I recommend to you. You can find a lot of information about our research projects, teams, and research grants. Research applications that you can find there. If you need any more information, just send an email to us and we will inform you. Next question if we have? No. Question from the audience here. If you have any question, please. Not just people from the online world can ask questions. There are some people here in person as well. So if you have any question, I'm glad to answer. Even more interesting to answer questions in person. One more question.
Are there any requirements for the MSc thesis? Should it be related to the future PhD research topic?
No, but of course, if you have done a research earlier and a master students in a given topic, then it's easier to you to continue. One of our students mentioned TDK. I wonder whether you know what is it. Probably not. This is a Hungarian abbreviation. In Hungary, there is a contest among master students who is the best in research in Hungary, and this is called scientific thesis of master students conference or something like that, if I translate it into English. So for our students, local students, master students, international ones as well, we recommend to take part in this kind of activities, so to join our research teams already as a master student and to prepare a research thesis and take part at the national level conference. And you may get some award, and then you are very welcome as PhD student immediately. So this is, of course, very good if you start research, as I mentioned, at master study time, yeah, but not an obligation, so not a requirement. You can do, however. There is one more requirement, that you have a good level of speaking English. So we prefer that you have a language proficiency certificate at least at B2 level, and if you don't have it at the beginning, but we can, you may have some problem if you don't have it, but you have to have such a certificate sooner or later as obligatory. This is part of your obligations during your studies for PhD. Any more question? If not, then again, I hope you got information which motivate you to apply for PhD studies. I would like to say thank you for our industrial partners being here, and for our PhD students sharing their experience, and I enjoyed it very much. I hope everybody who has followed us online has enjoyed as well. So see you next time. Goodbye.